Hey guys, and welcome to this lesson all about multiplying and dividing these rational expressions that we just introduced in our last lesson. And like I mentioned before, all of the skills that we talk about with these rational expressions are going to derive from the fraction skills that we've learned previously. So for example, let's take a moment to recall how we multiply fractions. And if I wanted to multiply the fractions 16 over 12 times 5 over 2, I think we're just going to multiply across our numerators, and we're going to multiply across our denominators, yielding the new fraction 80 over 24, which we can then simplify. And that simplifies to 10 thirds. And everything's groovy. And the strategy we're going to use with these rational expressions we see down here is exactly the same. I want to do this problem one more time in a slightly different way just to show you how these skills that we're going to use here are actually exactly the same as this skill here. So for instance, let's do 16 over 12 times 5 over 2 again. And what I'm going to do is I'm going to fully factor 16 and 12 into their prime factorizations. And we'll see why in a moment. And 16, I think, is the same as 2 times 2 times 2 times 2. And 12 is 2 times 2 times 3. So here is the new multiplication problem that I think we have on our hands. And why did I do this? I did this because I think there are a lot of opportunities for simplifying these fractions before we go ahead and actually multiply. And now note to self, for instance, I think in our first fraction, we can simplify 2 over 2. Those are going to simplify to 1. If you want to say cancel out, be my guest. For instance, we also know that this 2 and this 2, well, since we're multiplying here, it's almost like we have just one fraction going on. I mean, it's the exact same idea. I'm not going to draw that, but I want us to know that we can, for instance, simplify from this numerator and that denominator, and that's okay as well. And then I think we've got one more set of 2's that are going to simplify away. And so what's our product going to be now? Well, all we have left is 2 times 5, which is 10. And in our denominator, we have just 3. So note that we got 10 thirds again. And this strategy right here is going to closely resemble the strategy we're going to use when we multiply these rational expressions. And so basically, first things first, factor everything. Simplify as much as you can, and then multiply just like the regular fractions. So let's give it a try. So in this first example, let's factor everything. X squared minus 4x plus 4. I think that factors as x minus 2 times x minus 2. The denominator is already factored as x plus 5. In our second fraction, 3x plus 15, I see a common factor of 3. So I think we can write that as 3 times the quantity of x plus 5. Our denominator is a difference of squares. That's x plus 2 times x minus 2. Now, before we go ahead and simplify some of our factors, I want to take a moment to make sure we remind the reader of our variable restrictions. Remember, neither this denominator nor this denominator can equal 0. And if they were, then one of these fractions would be undefined and the whole expression would be undefined. So I think that x cannot be negative 5, it cannot be negative 2, it cannot be positive 2. So x cannot equal negative 5, negative 2, or 2. Now it's time to simplify. I see an x plus 5 in my numerator and denominator. Boom, they simplify to 1. I see an x minus 2 in our denominator and our numerator. Boom, they simplify to 1. Yielding us our final product of, let's see, I think we've got a 3 and an x minus 2. So 3 times the quantity of x minus 2. And in our denominator we have left just x plus 2. Note to self, I really like this as your kind of final form of your product. Some people would prefer that you distribute that 3 in your numerator and write it as such. I think that's more of a stylistic thing. So I leave that choice to you, but in general, that's going to be our strategy for multiplying these rational expressions. Factor everything, note your variable restriction, multiply like fractions, and you're good to go. And so we've got 2 more examples here, and if you want to try these on your own, the strategy remains the same. Feel free. If you want to, you can also just continue on with me and I'll walk you through them. So exactly the same strategy as before. The first thing we want to do is fully factor every one of these 4 individual polynomials. So in this top left one, I think we have a common factor of 2, so that's 2 times the quantity of x squared minus 2x minus 3, which I think is ultimately 2 times x minus 3 times x plus 1. We see that our factoring skills are going to be so prevalent in this section. So just a note, our denominator looks like x plus 5 times the quantity of x minus 3. Our other numerator looks like we've got a common factor of 7x here, so we can write that as 7x times the quantity of x plus 5. And our bottom right denominator looks like there's a common factor of 4 times the quantity of x squared plus 2x plus 1. and that is going to fully factor with 4 times x plus 1 times x plus 1. And note, there is a lot of dirty work to be done in these problems. And so what I usually do is I kind of do all this dirty work kind of off to the side, and now I'm going to rewrite all the fractions. I think I might have to go so far as to write them down here. So that's going to equal 2 times the quantity of x minus 3 times x plus 1 all over x plus 5 times the quantity of x minus 3. I think I need to manufacture a little more space for myself here. All of that multiplied by 7x times the quantity of x plus 5 over 4 times x plus 1 times x plus 1. All right, before we do any simplifying, let's make sure that we note our domain restrictions or our variable restrictions. Let's see, I think x cannot equal -5, it cannot equal +3, it can also not equal -1. So x cannot equal -5, 3, or -1. Let's see what we can simplify away. I see an x minus 3 in my numerator and denominator. I see an x plus 1 in my numerator and denominator. I see an x plus 5 in my numerator and denominator. All right, a lot of things are simplifying away. And I think we are left with a numerator of 2 times 7x is 14x. And our denominator looks like just 4 times the quantity of x plus 1. And I guess we could have done a little bit more simplifying. 14 over 4 will reduce to 7 over 2, so 7x over 2 times the quantity of x plus 1. And that would be our product in its fully reduced form, or fully simplified form right here. So I hope you're getting the hang of it, and if I walked you through this one, that's okay, but why don't you try this one on your own, and when you're done, why don't you play the video and see how it went. All right, so I hope that went well for you, and now it's time to move on to talk about dividing these rational expressions. Now, like I said before, all of our rational expression skills are going to stem right from our fraction skills that we learned earlier. So I hope that you recall how to divide 2/3 by 5/6. And we remember that whenever we divided fractions, instead we would actually take, for instance, 2/3 and we would multiply it by the reciprocal of 5/6, namely 6/5. And now it's just a fraction multiplication problem. And when we do this strategy with our rational expressions, it just becomes a rational expression multiplication problem, which we just learned about. So hopefully it's no problem. And I know we could just multiply across our numerators and get 12 over 15, but I'm going to show you this alternate strategy that kind of more closely resembles what we're going to do with rational expressions. Remember, we factor everything first, we look for simplifying opportunities, 3 and 3 simplify to 1, and we end up with our final product of 4/5. And so that's exactly what we're going to do with these rational expressions. And so these aren't too much of a conceptual leap from the multiplication problems that we just learned about. There is one slight difference. We're going to talk about it right now. Just like before, our beginning strategy is going to be factor everything first. Let's not rewrite this as multiplication just yet, and we'll see why. So I think we could rewrite this as a plus 1 times a minus 1. Of course, tons of factoring over a plus 1. Still going to keep this a division problem, divided by, let's see, a minus 5 times the quantity of a minus 1, all over a plus 3. Now, this is usually the time when we do our variable restriction, so let's do it. Of course, neither of these denominators can be 0, because if they were 0, the fraction would be undefined, the expression would be undefined. So a cannot equal -1. A can also not equal -3. All right, but I want to make another note. Of course, why can't these be equal to 0? Because then you'd have division by 0, and division by 0 yields an undefined quotient. And so, I'm going to repeat that. We can't divide by 0. And what we've got here is we've got a situation where we have one number divided by another number. So this number right here can't be 0 either. And if a were 5, or if a were 1, then this numerator would be equal to 0, this fraction would be equal to 0, and we'd have something divided by 0, which is no-go. That's going to yield an undefined result as well. So what's different about these division problems is there are going to be more variable restrictions. Here, a cannot equal -5 either. Excuse me, a can't equal 5. A also can't equal 1. So that's why I like to factor everything first before rewriting this as a multiplication problem. Find our variable restrictions. Now let's rewrite it as a multiplication problem, which is a lot of copying, I know, so thank you for bearing with me. A minus 1 over a plus 1. Now we're going to multiply by the reciprocal of that second fraction, just like we did before, over a minus 5 times the quantity of a minus 1. Now we're going to look for simplifying opportunities. I see an a minus 1 in our numerator and denominator. I see an a plus 1 in our numerator and denominator. And so I think our final result in this case will be the rational expression a plus 3 over a minus 5. Of course, with these variable restrictions. So that's the big difference between these rational expression division problems and multiplication problems, but as long as you're on top of these variable restrictions, you're going to be good to go. We've got 3 more examples here. I'm going to walk us through number 2, and then I'm going to have you definitely try 3 and 4 on your own, but if you feel like you've got the hang of it already, give these a try right now. Okay, let's proceed with number 2. Just like before, the first thing we're going to do is factor everything. So I'm actually going to zoom in a little bit and use a thinner ink. Okay, so this numerator right here, I see a common factor of 2. So 2 times the quantity of x squared plus 6x plus 5, which factors as 2 times x plus 5 times the quantity of x plus 1. This denominator right here looks like it factors as x plus 5 times x minus 2. This numerator right here, I'm going to do in hot pink just so we can keep everything clear. Looks like it factors as x plus 1 times x plus 7. And this denominator right here looks like it's got a common factor of 3 times the quantity of x squared plus 5x minus 14, which factors as 3 times x plus 7x minus 2. I'll be honest, it's a lot of work that goes into every single one of these problems, so I'm just trying to manage expectations here. Now that we've got everything factored, let's rewrite the original still as a division problem so we can more accurately find our variable restrictions. So we've got 2 times x plus 5 times x plus 1 over x plus 5 times x minus 2, still divided by x plus 1 times x plus 7 over 3 times x plus 7 times x minus 2. All right. Definitely can't have any denominators that are 0 because that would imply division by 0. So x cannot equal negative 5. X can definitely not equal 2. X cannot equal negative 7. And x can equal 2, but we already got that. Of course, like I said, we can't have division by 0, so we cannot divide by 0. So this fraction itself can't be 0, so the numerator can't be 0. So x can also not be negative 1. It can also not be negative 7, but we already took care of that. So, okay. Our variable restriction has been taken care of. Now I know it's a lot of rewriting, guys. Let's rewrite that as a fraction multiplication problem. So I do have the luxury of using the copy-paste feature. So we're going to have the same first fraction, and we're going to be multiplying that by the reciprocal of our second fraction. All right, so that's going to be our new numerator. This is going to be our new denominator. All right, now we are looking for simplifying opportunities. Let's see, I see an x plus 5 in my numerator and denominator. I see an x plus 1 in our numerator and denominator. I see an x plus 7 in our numerator and denominator. And I see an x minus 2 in our numerator and denominator. Oh my god. Which means that the final result, after all of that, is just 2 times 3 is 6. That is the simplified version of the quotient of these two rational expressions. What's crazy is that as long as x does not equal negative 5, 2, negative 7, or negative 1, because if it did, the whole thing would be undefined, if we substituted any other value for x, this whole problem, when you substitute it in and evaluate and divide, you get 6. I mean, I think that's beautiful. I think it's unbelievable. All right, so there are 2 more problems, and I would definitely like you to try pausing the video, trying these 2 on your own, and when you're done, playing the video and seeing how they went.